Hello everybody and welcome back to another video in our book tracking application playlist. And here we've been going through just various Jetpack libraries, seeing how we can combine them and put them together and use their combined functionality to create an app that's a little more involved and useful. So if you're just joining us, you can get that starting code for this video from the link in the description below, or you can go start at the beginning of the playlist. But if you've been following along up to this point, then you can simply just use the code that you ended up with from the previous video and you should be good to go. So up to this point, we've tried to put all of our UI and presentation logic inside of our presentation layer, and then all of our data logic inside the model layer. And actually, let me just pull up that diagram that we drew last time. So here's our presentation layer, and you have all of your UI logic within the views, and then you have all of your presentation logic within the view model. And then you have your data layer as well, which is going to have all of your data logic. However, most apps with a dedicated business scope actually use another type of logic, which is going to be known as business logic. And because most apps have a dedicated business scope, the stakeholders for that business are generally interested in an app's business purposes, and they provide requirements for those purposes. So let's imagine that we're building this book tracking application for a stakeholder who, let's say they always want to see their books listed in alphabetical order. So here you see we start with the Fellowship of the Ring, then the Two Towers, then the Return of the King, the Hobbit, A Christmas Carol, A Tale of Two Cities, right? These are clearly not alphabetized. But let's say we had a business requirement to always display our books alphabetized. Well, we could do that by going into our actual database and alphabetizing them in there. But let's pretend that we don't have access to do that. And we don't necessarily want to mess with the data that we're reading in. We just want to alphabetize the list of books after we've read it in. So where are we going to put that? What layer? If we look at our little diagram again, what layer do you think we should put that in? Well, we could put it into the UI level, and we could put it in one of the composable functions. But the problem with this is now any time that composable is recomposed, we're going to have to run that sorting logic every single time. And that's generally not a good idea because it's going to cause our app to perform slowly, and it's just a total waste of cycles on our CPU. So we don't want to do that. We could put it inside of our view model. And in fact, maybe we would if this was a sorting option that we wanted the user, like on the application. If up top there was a button for sorting it and alphabetizing it or reverse alphabetizing it or whatever, then maybe putting it inside of that view model would actually be a pretty good idea there. But in our case, we simply want to display the data sorted and not give the user any indication that we've rearranged anything that came in from that database. We don't really want the user to know. So because of that, I'm going to say we're not going to put it within our view model either, because that doesn't qualify as presentation logic anymore. The other option here is we could go on over to our data level, our data layer, and stick it inside of our repository. But this is where we store data logic and not necessarily business logic. So we don't really want to put it here either. But none of these options really seem to work or give us what we want here. So I'm going to actually introduce a better alternative shortly. But for now, I'm just going to put it into that data layer just to demonstrate why we don't really want to do that. So go back over to Android Studio, and let's go ahead and go into our books repository file. And let's find that get all books function. And within that get all books function, we have this books.getAll. So I'm just going to stick the sorting in the end of there for now. So just add a dot sorted by, and then in there, it.title. Now let's go ahead and build and run our application on our emulator here and see how it looks. And as you can see, we have A's and then D, J, M. So this does actually look like it's alphabetized. That is definitely what we want, but we have a problem here. So let's go ahead and let's say we've read A Christmas Carol and we want to mark that one off. So I click the X on that and it toggled it, but it moved it. And essentially, you can see here, it's now reordered the list how it was before, unsorted. What's going on here? Well, if you look within this same books repository file, let's go ahead and find our toggle finish DB function. And you can see here, again, we're calling books.dow.getAll. So what we could do, we could copy this code. We could come down here and paste it. And now it's going to sort it again every time that we toggle one of those check boxes. But this isn't really what we want to do here. Basically, we're now repeating code to fulfill our business requirement, and that's going to be confusing for people down the line. And if we ever need to come in here and update anything, well, now we have to update it in multiple places. And besides that, this repository is still in our data layer, so we don't necessarily want to be doing that. We essentially we want to separate our business logic out into a new layer. So if we look at our diagram again here, we have our presentation layer, and then we also have our data layer. But we've already said that we don't really want to stick this business logic into either of these, and we've seen the problems that have arisen when we stick it in the data layer. So what I'm going to do, I'm going to grab that whole data layer, and we're going to move it over, and then I'm going to grab my presentation layer and just kind of make room in between here. And basically what we're going to do is I'm going to make a new layer in between here called our domain layer. And then within this domain layer, we're going to put all of our business logic and rules and everything for that. Basically, the main reason for doing this is we want to separate out our business logic into a new layer so that we don't impact either our current data layer or our presentation layer, so that we can cleanly encapsulate it and reuse it later if we need to. And this is also going to make it much easier for testing down the line. So in what we're using here, which is an architecture called clean architecture, we don't want any of our business logic to be mixed in either in the presentation or the data layer. So by putting it in the new layer, we can faithfully fulfill all of the requirements that we have without impacting anything that we have right now. But we have a problem here. If we're going to implement this, our view model is actually connected directly to our data layer, because if you look in here, and actually before we look in there, let's go ahead and delete this sorting logic out of the repository because we don't want it in there. But if we go back over to our books view model, you can see that I have a reference to my books repository in there. Well, we don't want this. We want this to connect to something in our domain layer, which is then fetching that layer or fetching that data from our data layer. So we don't want the presentation layer ever reaching out directly to the data layer. So what are we going to put inside of our domain layer to actually accomplish all of this? Well, if we're going to follow clean architecture best practices, which we are, then any repeatable business logic should be encapsulated into something called a use case. So use case is simply a class that's used to extract any rules or requirements for an application's different functionalities into our domain layer. So separating out this business logic into the domain layer is actually going to benefit us in several different ways. One, it's going to majorly simplify the testability later on, because now all of our business logic is going to be in their own simple classes, and we can test all of these separately from the other data and the presentation logic. Two, we're also going to be able to avoid any repeated code and allow for more reusability of our code later on. And then three, it's going to improve the readability of our code because each piece of business logic is going to be broken out into the individual use case. So let's go ahead and implement our first use case here. So come on over to your project window, right click on your top level application package, the book tracker, unless you named yours something different. We're going to go to new Kotlin class or file, and then I'm going to call this get books use case. And now within this file, like I said before, in our view model, we have that reference to the repository. Well, we don't want that there anymore, so I'm going to put that inside of my use case. So let's go ahead and do that. Private val repo. This is going to be my books repository, which is of course going to be equal to my books repository. And then there's just going to be one function, and in this case, one very simple function in this get books use case. It's going to be suspend because we're going to be running this on a coroutine because it's going to be exercising, or it's going to be performing a network call. So suspend operator fun invoke, and then it's going to return a list of books. And then inside of this, all we need to do is return repo dot get all books dot, and then that same logic that we deleted earlier, which is sorted by it dot title. So what's going on here? Basically, this code is going to get that list of books from our books repository, and it's going to apply that alphabetizing logic that we had before. But what's going on with this invoke up here? And then what about this operator keyword? What are we using that for? Well, in Kotlin, when you define an invoke operator, which is what this is, when you define an invoke operator for a class, and then you can call it without having to specify any function name. And the reason we want to do that is because, one, this get book use case is already pretty specific about what we're doing, is it's getting the books. And then two, it's going to shorten our code and make it much more readable later on. And we only have one method in this function anyway, so we don't need to worry about having, get books use case dot get all books. It's pretty clear what we're doing anyway. Now we've fixed our sorting problem for that. But is there any other business logic that we might want to extrapolate out into, or encapsulate out into a use case? Well, not really at least not in the view model. But if we go on over to our books repository, and then if you look down here, we've got this toggle finish database function. And this we could, so this happens every time we mark one of these books in our application. Every time we toggle one of these, it's going to go ahead and mark that for us. And for example, just for an example here, we could say that toggling this is a requirement that came to us from our stakeholder, or who's ever having us make this app. And if that's the case, and this can in fact be considered business logic, and we can move that into our domain layer as well. So let's go ahead and extract this out into a use case. So to do that, come down here, and what I want to change, I want to get rid of this old value, and I'm just simply going to use value now. And instead of, again, old value down here, we're going to change that to value, and then leave everything else alone. We don't need to be negating that anymore because we're going to do that in the use case itself. So come back over to your project window, right click on your top level package. We're going to do a new Kotlin class or file. And this one I'm going to call toggle finished use case. Okay, and then inside this use case, again, we're going to put a reference to our repository. So private val repo, going to be a books repository equal to, equal to books repository. And then again, we're just going to have one function inside here. So suspend operator fun invoke. And this one, we're actually going to need a couple different parameters here. So we need an ID for the ID of our book item. And that's just going to be an int. And then we'll do our old value here. And that's going to be a Boolean coming in. Now, inside of this function, we have the parameters. We also actually need to return something here. So I'm going to return a list of books, or a list of book objects. So we'll define that. And then inside of this function, all we need to do is say val new finished. And we're going to set that equal to old value dot not. We're going to negate that one. And then all we need to do at this point is return repo dot toggle finished db id new finished. Did I spell that wrong? I sure did. New finished. Okay, so we get our new finished value, we negate it, or we get our old value in, we negate it in new finished, and then we send that to our repository function. So again, we're using our operator keyword and then our invoke. because this toggle finished use case, it's pretty clear what this function is doing. We don't need an extra function name to specify that. And I know there's really only one, maybe two lines of business logic here. And this is a pretty simple task. And oftentimes for really simple stuff like this, people will skip over the use cases entirely. But it can get much more complex and complicated. And I think that this is still a nice way to keep your code nice and clean. So let's go back into our books view model in here. And what we're going to want to do in here is actually add a reference to the two use cases that we just created. So we can do that pretty easily. Val toggle finish use case equals, it's just going to be a toggle finish use case, and then private val get books use case is going to again be equal to just a get books use case. And typically that is going to be lowercase. So now we can actually delete this reference to our books repository because we don't want that anymore. And if we do that, we're going to get a couple errors in here for anywhere where we're using that repository. And all we need to do here is basically replace those errors with references to our new use cases that we created. So down here, this repo.toggleFinishDB, I'm going to replace that. I'm going to replace that with toggle finish use case. And then in there, I'm going to hand it ID and then book.finished. And then this line, actually, we won't really even need this line anymore. So we can go ahead and delete it because our negation is happening inside of the use case instead. And then up here for this error, all we need to do is get rid of that and replace that with our getBooks use case. Now let's run our application one more time and see how it behaves. So here's our application again. It is sorted. So if I click on one of these, like A Tale of Two Cities, you can see it actually reordered everything again. So what's going on? What did I miss here? Well, let's go back into Books repository. And in our Books repository, you can see we still have this books.dow.getAll. And we're using that to essentially return our list of books. But we don't really want to be doing that here. So let's delete that line. And now our toggle finish DB doesn't return the book list. In fact, it's not returning anything at all from the DAO, but that's okay. We can do that in our use case instead. So come on back now into our toggle finish use case, and this is no longer going to work. So I'm going to go ahead and delete that line. And instead of that, I'm going to say repo.toggleFinishDB. We're going to hand it our ID and then our new finished. And then after that, I'm going to return my getBooks use case, so that it's using that sorting logic that we put in there, and then run invoke on it. And you'll notice two things here. One, I can call one use case from another use case, so these actually can build on top of each other. And two, I don't actually have an instance of this getBooks use case, but I can call it using just my .invoke operator to do that. Now, if we run this, is actually going to be quite a delay. So let me go ahead and run that and see what that looks like. So if I click on that now, you could see it works, but there's, what is that, maybe a half a second delay every single time. So what's causing our delay here? Well, basically now we're running this getBooks use case from our toggle finish use case. And if we look in our getBooks use case, you can see that we're using repo.getAllBooks. And if you look in our repository, you can see that our getAllBooks function is calling our refresh cache function, which actually makes a network call. So we don't want to be doing this because basically anytime we now toggle one of these, we're going to update our entire book list from the network using an HTTP call. And this is not going to be efficient at all. This is going to cause serious delays on everything. And it's going to cause big problems for just use of the app and also for testing. So we shouldn't be doing a network call after every single UI interaction. So let's add a new function in here in our books repository. And this function is going to pretty much be for getting a list of books from our local cache only. So suspend, because this is going to be doing a database call. So this is going to be run on a coroutine. Suspend fun get cached books. The cache again is our room database that we built in a previous video. And this is going to return a list of books. And then in here, I'm going to return with context. And we're going to use dispatchers.io because this is a database call. And then we're going to do return at with context books DAO.get all. So now that we have this function to get books from our local cache only without doing a network call, let's go ahead and add another use case so that we can implement that function inside of a use case. So back in the book tracker, new, we're going to do a Kotlin classer file, and then in here we're going to make a new file. We're going to call it get sorted books. Get sorted books from cache use case. And then in here, private val repo, we're going to have a reference to a repository. This will be a books repository, which is going to be equal to a books repository. And then again, we're going to do just a single function here, suspend operator fun invoke. And this is going to return a list of books again. And then all we need to do in here is return repo dot get cached books dot, and then we'll do sorted by it dot title. So now we have a use case that we can use to get a list of our sorted books from directly from our local cache in our room database without having to make a network call every single time. So let's go on back to our toggle finish use case. And basically in here, we're going to use this new use case that we created instead. To do that, let's come up here and add a reference to that new use case. So private val get sorted books from cache use case equals get sorted books from cache use case. And then down here, instead of returning get books use case dot invoke, I'm going to get rid of that, and we're going to use that get sorted books from cache use case. And now when I run our application, you can see that every time I click one of these, we're no longer going to have that long delay, because now we're just getting that from the cache locally instead of going out and doing an HTTP network call every single time. However, now we've added a new problem here. So if you look in our get books use case, we have our sorting logic. And then if you look in our get sorted books from cache use case, we also have our sorting logic here as well. So we have this duplicated, and that's not something that we necessarily, we don't like duplicated code. So we're going to try to fix that. So let's go back into our books repository, and up here, let's find our get all books function. So here's our get all books function. So instead of actually returning anything from this function, I'm going to get rid of that entirely. So I'm going to delete my return type, and then down here, I'm going to delete my return statement. Now that we've done that, we're not actually returning anything. All we're doing is updating our cache. So from here, what we're going to need to do is, well, first let's rename our function so that it is more accurately reflecting what we're doing now, because we're not getting and returning the books, we're only loading them into our cache. So I'm going to right click on that function name, refactor, rename, and then instead of saying get all books, I'm just going to call this function load books now. And that should refactor it across the application wherever we're using that. Okay, now let's go into our get books use case. And then here you can see right off the bat, we already have a problem because we're expecting to return that data from our load books function, which no longer returns anything. So in here, what we need to do Let's go ahead and add another variable up here. And it's going to be essentially a reference to our get sorted. So get sorted books from cache use case equals get sorted books from cache use case. And then down here, instead of using that load books function, well, we'll still use it, but instead of returning that, because that's not returning anything, I'm going to say repo.loadbooks. And then after that, we're just going to do return get sorted books from cache. And now we don't have that repeated code. But we do have one issue still here, and that's we have our get sorted books from cache, and then we have our get books use case, but that's not clear enough for what we're doing anymore. So I'm actually gonna right click on that, and we're gonna refactor that as well. Refactor, rename, and instead of naming that get books use case, I'm gonna name that get initial book list from net. So get initial book list from net use case, and now we know exactly what that's doing. So go ahead and click refactor on that. And now if we build and run our program, we should see that our delay is totally gone and we don't have any repeated logic, and everything's working as we've expected. So this has been our first introduction into clean architecture, and we'll probably have two more videos after this covering this topic. And in this video, we just talked about use cases, and we talked about how we can take the essentially our business logic out of our presentation layer and then out of our data layer and put that into our new layer that we are calling our data layer. Sometimes you'll hear people say a model layer. And basically we're separating all of that logic out into our use cases. Now we're going to have two more videos talking about clean architecture, and we're going to talk about basically how to create a package structure over here, because this is getting pretty disorganized and pretty unorganized in our project window. And then also we're going to talk about how to make our domain models that we're actually going to be using in our application itself. So definitely stay tuned for all of those upcoming videos. And if you found this video helpful, then definitely like and then subscribe to our channel and stay tuned for additional videos. And we'll see you in the next video.